Okay, so in this section, we're going to talk about properties of functions. And in order to do the properties of functions, we need to understand these two important concepts, an even function and an odd function. So an even function, an example would be like f of x equals x squared, okay? And the graph looks like this. So as you notice the graph, the orange graph here, again, this is a parabola, and it's positive, so it's a happy parabola. You notice that there's symmetry. It's symmetric by the y-axis. So another way to say that is it's reflected over the y-axis. Okay? So it's like looking in the mirror. Okay, and the mirror is the y, and each side is the same, right? So that's why they say it's symmetric by the y-axis, or it's reflected over the y-axis. In regards to this odd function, and a specific example will be f of x equals x to the third power. And notice you have symmetry by the origin because the origin is in the middle, right? So this upper half of the graph, top right, is reflecting over the bottom half, all right, through the origin. Or it has rotational symmetry. So if you rotate it, you'll get the same graph over and over and over. Okay? So that's what that information there is talking about. Now, let's explore a little bit more about what it means to be an even function and an odd function. So if we have here f of x equals x squared, right? So f of x is equal to x squared. And um, if I pick, say, um, 2 points. So let's say I have a positive 3 and I have a negative 3. What's going to be the output? Okay. So if I plug in f of 3, I'm going to have 3 squared, which is 3 times 3, which is 9. If I plug in negative 3, I'm going to have negative 3 squared, which is negative 3 times negative 3, which is also positive 9. So these points here, right? 3 and negative 3, if I were to plot those on the um, graph here, they're going to have the same y value. In this case, 9, right? It spits out 9. So they get the same y value, okay? The same y value, all right? So when x is 3, the y value is 9. When x equals negative 3, the y value is 9. So all the way across there, okay? So what does that mean? That means then if we were to find out whether a function is even or not, we just need to plug in negative x. So if I plug in a negative x in here, let me do it on this side here on the right. If I plug in a negative x for my function, I'll have a negative x squared. And that's going to give us a negative and a negative. So this would be a negative 1 square, and then you have x squared, right? If you were to break that down. So that negative 1 square will be a positive, and you still have the x squared, right? So that will be a positive x squared or just x squared. Okay? So notice that at the end, we get the same output. Okay? We get the same output for our original function and when we plug in the negative x for the original function. So the bottom line here is if we have the same output, okay, then that means we have an even function. Okay, we have an even function. Now, let's talk about odd symmetry. And let me use a different color there. Okay, so for the odd symmetry, we are using f of x is equal to x cubed. And I'm going to go through the same process again. Okay, I'm going to plug in positive 3 and negative 3. Okay, positive 3 and negative 3. So if I have f of 3 and I plug it in for my function, x cubed, okay, we're going to get what? 3 times 3 times 3, which is 27. If I plug in negative 3 for my function, that's going to be negative 3 to the third power, and I'm going to have a negative 27. Okay, so here at 3, somewhere up here, we get 27. We plug in negative 3, somewhere on here, we get negative 27. Okay, so notice then we have a positive and then we have the opposite, negative 27. So if the output is opposite, okay, what does that mean? Well, again, in order to determine whether it's an odd function, we're going to go through the same process of plugging in the negative x. Okay, so we have f of negative x. So that would be negative x to the third power. And that's going to give us negative 1 to the third power times x to the third power. And negative 1 to the third power is just negative 1 times negative 1 times negative 1, which is a negative. And then we have x to the third power. Okay. So what does that mean? Well, notice again, these are opposite. If I have a positive x cubed for my original, when I plug in a negative x to my original function, it gives me the opposite. It's a negative now. So the bottom line here is we have the opposite output. Okay. Then we have an odd function. It's an odd function. Right? Now, you can say, well, it's x to the third, that's an odd number, so that's an odd function. It's x to x squared, that's an even function. It's true, you're correct. However, what if there's other terms added to it? Right? X to the third plus x squared plus 1, x plus 1. Is it even or odd? All right, or maybe it's being divided by another term, x to the fourth or x to the fifth. Is it even or odd? So again, it's for these ones, yes, it's pretty cut and dry, but if you add other terms to it, it gets complicated, and that's what you need to do is you plug in that negative x to determine if that function is even or odd, or sometimes it's none of it, neither. Okay, so anyway, that's a great segue to what we're going to do, right? It's basically do problems and figure out whether the function is even or odd or neither. Okay, so in these problems, they want us to determine whether it's an even, odd, or neither function. So to determine whether it's even or odd, we just plug in negative x. Okay, so if it spits out the same output as the original function, then it's an even function. If it spits out the opposite, meaning one is positive, one is negative, that's the only difference, then it's an odd function. But if it doesn't do any of that, then it's a neither function. Okay, so we have f of negative x equals 4 times negative x to the third power. Okay, so I'm just going to break this down. So we have 4 times the negative x, that's negative 1 times x, or I can write it as negative 1 to the third times x to the third. Okay, so that is 4 times negative 1 to the third, that's just negative 1, because it's negative 1 times negative 1 times negative 1, which is negative 1. And then we have x to the third power. Well, 4 times negative 1, that's just going to give us negative 4, and then x to the third. Okay, so now what do I do? Well, we need to look at our outputs. Okay, so for this one, we have our original function, we have 4x cubed. And then our when we plugged in negative x into our function, we get an output of negative 4x third. So notice that the original is positive, and when we plugged in the negative x, it gave us a negative. Everything else is the same, but the only difference is we have a negative now. So these are opposite, okay? So these are opposite outputs. So that means, right, we have opposite outputs. So that means this is an odd function, right? It's an odd function, okay? All right. All right. So again, what we need to do here is we need to plug in a negative x um, for a function. So we have g of negative x. So negative 3 times negative x squared minus 5. Well, the negative x squared, because it's being squared, that's just going to be positive, right? So we have the negative 3 still in the front, and then this will become just x squared. The negative 1 squared is a positive, will give us a positive. And then we have the minus 5. All right, so here's our original function. Here is the output when we plugged in negative x, and we get the same. So that means then this here is an even function. Okay, so it's an even function. All right. Okay, so then we're going to do exactly the same thing for this one, right? So I'm going to plug in the negative x in. So that'll be 1 over negative x squared. And so negative x squared is just going to be a positive x squared. So that'll be 1 over x squared. So again, I look at my original function and I look at the output after I replace x with negative x, and I still get the same output. So this one as well is an even function. Okay. Okay, so again, we're going to plug in negative x into our function. So we're going to have h of negative x, which is going to be negative x over negative x squared minus 1. So we still got negative x on the top, and then the negative x squared just becomes x squared minus 1. Okay, so now I can write it this way, or I can have the negative in the front and have x squared minus 1, or I can have the negative also in the bottom and have x squared minus 1. Okay, so this one here, as well as this one here are all the same. You can write it in those three different ways. Okay, I could have the negative on the top, the negative in the middle, or the negative in the bottom. They're all the same. But we just have to understand that this is just going to be opposite, right? Because this is a positive x over x squared minus 1, and we have a negative x over x squared minus 1. So in this case, our conclusion here is we have an odd function. Okay, very good. Okay, so again, we want to determine whether each of these functions is either even, odd, or neither. And so before we do that, let's explore the negative. So if I have the cubic root of -1 versus the square root of -1, right? So if I look on the inside here, -1, and my root is 3, so that means I want to match this root with the power inside. So what I mean by this is that I want to multiply this number -1 3 times so that it spits out a -1. So -1 times -1 times -1, okay, is going to give me a -1, right? So I can rewrite this as -1 raised to the third power, okay? Because again, -1 times -1 times -1 equals -1, right? So -1 to the third is the same thing as is equal to -1. So I can rewrite that. So in this case then, I'll have the cubic root of -1 to the third. Okay, because again, this here is the same thing as we rewrote it. Okay, they're the same thing. So that means then I can get rid of the root here and the power, leaving us with -1. So it works. Okay. However, for this one, we want to multiply, since we have a root of 2, we need to multiply something twice, but it spits out a -1. So if I have -1 times -1, it doesn't spit out a -1. It spits out a +1. Okay? So a -1 square spits out a +1, but I want a -1 because that's what I'm looking for. So it's not possible. Okay? We can't find a -1 multiplied to itself twice that will give us a +1. So that's why in this case, this is, again, not possible. All right, it's not possible. You can't take the square root of -1 in the real world. So we're going to apply the same thing over here. So in this case, we have f of -1, so the cubic root of -1. So again, I can rewrite this as -1 raised to the third power. I'm sorry. Let me backtrack. I meant -x, not -1. So cubic root of -x. And then I can rewrite this as -1 raised to the third power, and then x to the third. Or in this case, just x. Okay? So I can break this down as the cubic root of -1 to the third times the cubic root of x. Okay? So in this case, the cubic root and the cube are going to eliminate. And then that means we only have a negative in the front, and then we have the cubic root of x left over. Okay? All right? So notice we have a positive cubic root of x, and then we have the opposite of cubic root of x, which is the negative. So in this case, we will have an odd function here. Now, let's do the same thing for the square root of x. So we're going to have f of -x, take the square root of -x. Again, I can break this down to -1 squared times x and take the square root, right? However, -1 square is not -1. It's +1, right? So, but I want a -1 in the front. So I can't do it, right? Because I have a +1 and I need a -1. So in this case, it's not possible. So this one is neither. Okay.